There have been a couple incredibly influential science experiments through time, and even fewer that were so influential that they completely changed their field of study. One such experiment is known as the Michelson Morley Experiment, conducted by Albert Michelson and Edward Morley in 1887. Take a look at these waves. They are made out of water. And common sense would tell you that if there's no water there, then there would be no waves. To extend on this, we know that sound, which is a wave, must travel through something. With nothing for the sound to travel through, there is no sound. It was shown quite a few years prior to the Michelson Morley Experiment, in 1801, that light exhibits properties of a wave. So any amount of common sense would tell you that there must be some medium for the light to travel through, because, of course, there is light. Physicists called such theoretical medium the æther. This æther was the material that permeated throughout the universe and provided a medium for light to travel through the vacuum of space. The existence of the æther was never proven, and that was something that Michelson and Morley wanted to change. They designed an experiment where they could utilize the movement of the Earth through the æther to measure the difference in the speed of light. The idea being that if light is traveling through the æther in a constant velocity, and the Earth is traveling through it in a different velocity, then the perceived speed of light of the Earth will be slightly different than the actual speed. With the speed of light being so massive, especially compared to the speed of the Earth around the Sun, any device built for this task would either have to be insanely accurate or very large, which proved to be quite the challenge to overcome. To solve this, they built what is now known as a Michelson interferometer. This mechanism shot a light wave into a half-silvered mirror, or a beam splitter, which, as the name would suggest, splits a beam of light into two. From the half-silvered mirror, both beams of light traveled into normal mirrors and were reflected back into the beam splitter, where they converged. If there was any discrepancy in the position of the light waves caused by one of the beams traveling slower than the other, then the intensity of the light wave would change and, like the double slit experiment, would create an interference pattern. No matter how many times the experiment was conducted, it returned a null result. The light traveled back the exact same speed and matched back up perfectly. This null result contradicted not only intuition, but also hurt the viability of theories that other scientists had made. This new understanding of the universe left a void that no one could understand for quite some time. That was, of course, until Einstein came along. This experiment laid the framework that the theory of relativity and the theory of special relativity were built upon. It provided the idea that the speed of light was independent of the speed of the observer, which was majorly counterintuitive. Einstein theorized that since the cosmic speed limit cannot be exceeded and thus light cannot travel faster to keep up with observers, it was concluded that it was instead the observer's perception of time that warped to maintain the speed of light while traveling at different velocities. It can be argued that without the null results of the Michelson-Morley experiment, Einstein wouldn't have had the necessary framework to build his theories, and our current understanding of the universe wouldn't be the same.